Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we are going to do how to solve quadratic equations, and this video is especially for SAT 2016 and onwards, right? So this video is especially made for the new SAT, or it's also called as the redesigned SAT. Right. So let's go ahead and get started, guys. All right. So we have our email address. This is our email address. This is our website, and this is a Facebook page where you can give us your valuable like. So let's go ahead and move forward, guys. Okay. So let's understand what is quadratic. I mean, what is the meaning of quadratic? Since SAT students, since grade 12 students are actually watching this video, some of you would actually already know what quadratic is because you've actually taken math. And for the students who have not actually taken math in their high school, they'll probably have a vague idea what quadratic is. So let me go ahead and put that down here. So a quadratic equation is equation where your variable x can have a maximum of two values. So a variable x can have maximum of two values. Well, usually you get equations like this, like x plus 2 is equal to 3. Here x has a single value, isn't it? X has just one value, which is actually equal to x is equal to 3 minus 2, which is 1. So x have a single value in this equation, which is why we call this equation as a linear equation. Well, there's another equation called a quadratic equation. So quadratic equation, just like linear equation has the maximum power of x is 1, the maximum power of x in a quadratic equation is 2. So you have the equation as x squared, let's suppose x squared minus 5x plus 6. Now this over here is a quadratic equation, right? So this over here is a quadratic equation. So if I say, let's suppose this is equal to 0, this actually becomes a complete equation, and this is actually going to have two different values for x. X is going to have two different values. So those two different values which are there, we actually call these two different values as the roots of the equation. So what do we call them? We actually call them as the roots of the equation. So if you actually understand, let's suppose if I say y is equal to x squared, this is one of the most simplest quadratic equation that you'll ever see. That is y is equal to x squared. And graphically, if I want to show graphically what y is equal to x squared looks like, so y is equal to x squared. So when x is 0, y is 0. When x is 1, y is 1. When x is minus 1, y is 1. So this is how it looks like. So if I just connect all the dots, this is how y is equal to x squared looks like. And this shape is just known as a parabola. Right, so you don't need to worry about these fancy names because that's what make them look hard, but they're not actually anything in it. They're actually really easy. They're actually really easy and really systematic and predictable equations. So y is equal to x squared. It's actually one of the most easiest type of one of the most basic quadratic equations ever, and this is how y is equal to x squared looks like. So this is a quadratic equation, guys. Now if I move forward and if I talk about the translations in quadratic equations, so let's suppose I'm going to talk about the translations in quadratic equations. So the most easiest quadratic equation is y is equal to x squared. Right, so y is equal to x squared looks something like this. So y is equal to x squared looks something like this. Fine. Now, if let's suppose I want to talk about y is equal to x squared plus 2. Now, how will this look like in terms of translation? So y is equal to x squared plus 2 will just move the graph up by 2 units. Why? Because when you substitute x as 0, y is actually equal to 2. So when you substitute x as 0, y is actually equal to 2. So you substitute x as 0, y is 2. So that means what has happened to the graph? The graph has gone up by 2 units. Fine. So let's suppose if I say that y is equal to x squared minus 2, then what will happen? So when you substitute x to be 0, y is actually equal to minus 2. So what is going to happen here? The graph is going to go down by 2 units. So this is what we call as the vertical translations. I mean, it goes up and it goes down. If you add a number, it goes up. If you subtract a number, it goes down. Now, there are two more translations that I want to discuss right now. right? That is, let's suppose if I say y is equal to x plus 2 whole square, then what is going to happen? Now, if you want to draw y is equal to x plus 2 whole square, just give me the value of x where y will be 0. At x is equal to minus 2, y is actually going to be equal to minus 2 plus 2 whole square, which is 0. So at x is equal to minus 2, my curve is going to be 0. So that means this is the way the curve is going to look like. That means what has happened here? The curve shifted left by 2 units. Fine. And let's suppose if I say y is equal to x minus 2 whole square, then what is going to happen? If you substitute x as 2, y is actually going to be 0. So that means at x is equal to 2, y is going to be 0, which means the graph has shifted right by 2 units. Fine. So these are the 4 translations that I want to talk about right now. There are a couple more which I don't want to talk about them right now. I'll actually talk about them later in future videos. But these are the 4 which are very important. Like from here, you can actually make up any quadratic equation. So all the quadratic equations you can actually make up like this. So there are 4 translations that I will discuss again. That would actually write it again. So that is that if you have a quadratic function, let's suppose if you have a quadratic function y is equal to f of x, it can be any quadratic function, right? So if you do f of x plus a, then what is going to happen? The graph will shift up by a units, right? If you do f of x minus a, then what will happen? The graph will shift down by a units. And if you replace x with x plus a, then it will go to the left by a units. And if you substitute x as x minus a, then it will go to the right by a units. So these are the 4 translations that I want to talk about right now. And these are very, very important for SAT. That is shifting up, shifting down, shifting to the left, and shifting to the right. Fine. So these are the translations. So now what I want to talk about is, I want to talk about how to solve a quadratic equation. How do you solve a quadratic equation? What do you mean by solving a quadratic equation? Solving a quadratic equation means, so let's suppose we have a quadratic equation. Let's suppose x squared minus 5x plus 6. Solving the quadratic equation means equating it equal to 0 and finding the value of x which will actually equate it to 0. So you're going to get a maximum of 2 values. You can get even 1 value or you can get 2 values as well. So you're going to get a maximum of 2 values. And those 2 values are called the roots of the equation. So what are these 2 values called? These 2 values are called the roots of the equation. So if let's suppose x is equal to 3 is satisfying this, that is 3 square minus 5 into 3 plus 6 is actually equal to 0. So you could see that 3 is actually the root of this equation. So that means the quadratic equation is actually nothing but x squared minus 5x plus 6 is y, and you're equating y to be 0. That means at the root value, what is going to happen? At the root value 3, this function is going to cut the x-axis. So what is going to happen? At the root value 3, the function is going to cut the x-axis. There's going to be another value as well, because the function is going to come around and cut the axis again, right? So this could probably be 2 or anything. So there are 2 values when the quadratic function, this parabola, graphically this parabola can actually cut the x-axis at maximum of those 2 points, and these 2 points, guys, are called the roots. So what are these 2 points called? These 2 points are called the roots of the function. Better take notes of this. This is very, very important. So these 2 values are actually called the roots of the function at which y is equal to 0, because this is the x-axis, and you would know that at x-axis y is actually going to be equal to 0. So that's there. So we know about what are roots, right? So let's see, how do you find the roots? That is what I call, how do you solve the quadratic equation? So finding roots, right? So let's go ahead and know how do you find the roots, or that is also known as how do you solve a quadratic equation, right? So there are three methods by which you can solve a quadratic equation. The first method by which you can solve a quadratic equation is splitting the middle term. So splitting the middle term is the first way in which you can solve a quadratic equation. So let's suppose if you have a quadratic equation, x squared minus 5x plus 6. Right, so let's suppose this is your quadratic equation and you want to solve this. That means you equate it to 0. You want to solve this equation right here. So how do you solve this quadratic equation? Now usually the general way of denoting a quadratic equation, the general way is y is equal to ax squared plus bx plus c. First we write the term with x squared, then we write the term with x, and then we write the term with not x at all. So that is basically x to the power 0. So this is how we generalize, this is how we write a quadratic equation. First the highest power of x, then the next higher power of x, and then the least power of x. So so you can't write the quadratic equation as this. This would be a wrong way of representing a quadratic equation, because when I talk about the middle term is the term with the x value. So how do you split it? I mean, there are so many ways in which you can actually split this middle term. Well, you have to split this in one particular way. What is that particular way in which you want to split it? So you want to split b in such a way, so you will split this 5 in such a way such that the product of two numbers, is the product of this number and this number. Right, so you will split this in, let's suppose, p and q, such that the product of p and q is actually equal to the product of a and c, and p plus q is obviously equal to b, because you're going to be splitting b into p and q. So you want to find two numbers whose product is 6. You want to find two numbers whose product is 6 and whose sum is minus 5. Well, this is where a little bit of trickery comes in, a little bit of intuition, and a little bit of art comes in. So what you have to do is you have to break negative 5 in two numbers. I would break them into negative 3 and negative 2, because negative 3 into negative 2 actually gives me 6, and negative 3 plus negative 2 actually gives me negative 5. So this is how you're actually going to break a quadratic equation, and this is how you're actually going to split the middle term. So if I have this quadratic equation, x squared minus 5x plus 6 is equal to 0. Now you're going to see the magic here. So this negative 5 is actually going to get split into two ways. That is negative 3x and negative 2x plus 6 is equal to 0. Now you have two terms here. You have one term here and one term here. Try to take as much as common out of these two terms. I mean, try to take as much as common from x squared and 3x. What is common between x squared and 3x? X is common between x squared and 3x. So you're left with x from here and you're left with 3 from here. And what is common with negative 2x and 6? Negative 2 is common from negative 2 and 6. So this, when divided by negative 2, gives you x, and 6 when divided by negative 2 actually gives you negative 3. So your objective is to make sure that you get a same variable here, same value here, x minus 3 and x minus 3. Now what you can do is, from this and this, you can actually take the x minus 3 out, you can keep the x minus 3 here, and from here you'll be left with a value of x, and from here you'll be left with a value of minus 2, and then what have you done is, you have actually solved the quadratic equation, or in here you have actually factorized the quadratic equation. So from here, what have you done is, you have actually reached here, that is x minus 3 into x minus 2 is equal to 0. So from here, so when you say that either x minus 3 or x minus 2 is equal to 0, that means either x minus 3 will be equal to 0 or either x minus 2 will be equal to 0. So from here, either x is equal to 3 or x is equal to 2. So these are the two roots of this equation. X is equal to 3 will satisfy this, x is equal to 2 will satisfy this. And let's suppose if you want to draw the quadratic equation, you will draw the quadratic equation like this. It will cut the x-axis at 2, it will cut the x-axis at 3. That means the quadratic equation is actually going to be like this. So just by knowing, just by seeing the quadratic equation, what I've done is I've actually solved the quadratic equation, and I know that how it behaves and how it looks like. Now this splitting the middle term should be instant. I mean, it took me literally 5 minutes to actually explain this to you, but it should be instant, and that will come with practice. So I'm gonna explain this splitting the middle term again. So how do you split the middle term? You have a quadratic equation, make sure that it's written in a proper format, and then check out the middle term. You have to split the middle term in such a way, in such two numbers, such that their product is actually equal to 6 and their sum is actually equal to, sorry, 6 into 1, and their sum actually has to be equal to -5. And from here you actually find those two numbers. And here from hit and trial, I found those numbers to be -3 and -2. This is something that will be very easy for you once you actually practice some questions on this. If you don't know how to split the middle term, guys, I would recommend don't start solving the SAT questions yet. First, develop this skill, know how to split the middle term. So that's one way you can actually solve a question using splitting the middle term. The next way in which you can solve a quadratic equation is, it's one of the easiest way, that is by using the formula. Now, not all the quadratic equations can be solved by using the formula. Why? Because you use by splitting the middle term. Why? Because when you split the middle term, it's always easier for you if the roots are integers, because if the roots are integers, then it's easy for you to split the middle term, because it's easy for you to see the numbers, to split the numbers. But let's suppose the roots are square root 2 plus 3 and square root 2 minus 3. Then will you be able to get that? Will you be able to split the middle term in such a way? No, that would be waste of time. So if you're not able to split the middle term, then you move to the next method, which is known as using the formula. Now, it says that if you have a quadratic equation, y is equal to ax square plus bx plus c. So if you have a quadratic equation, y is equal to ax square plus bx plus c, then the roots are going to be, roots means when is this going to be 0, x is going to give you two values. Let's suppose those two values are x1 and x2. So x is going to give you those two values. Those two values are given by this formula, that is minus b plus minus square root b square minus 4ac divided by 2 times a. I've actually derived this formula in one of our quadratic equation videos. I have made videos where I've actually talked about the concept itself. Here I'm talking this quadratic equation in terms of SAT, right? So in here what's happening is, this is the formula, and this is the quadratic equation. It is going to cut the x-axis at 2 different points, and those 2 different points can be calculated by this. So let's suppose if I have a quadratic equation, the same one, x square minus 5x plus 6. So in this case, a is 1 because it's 1 here, b is -5, as you can see it's -5, and c is 6. So if I try to find the roots are going to be equal to minus b, that is minus 5, which is 5, plus or minus b square, which is 25, 5 square, which is 25, minus 4 into a into c divided by 2 times a. So this comes down to be 5 plus or minus, this is 25 minus 24, 25 minus 24, which is actually 1 divided by 2. So 2 roots are 5 plus 1 by 2 and 5 minus 1 by 2, which is 6 by 2, which is 3, or which is 4 by 2, which is 2. As you can see in the previous case also, we got these two roots, that is root 3 and root 2. So I hope you're able to understand this. So these are the 2 roots which are there. So this is how you solve a quadratic equation using a formula. Now here's one more thing that you can actually that benefits you to know the formula, that is how do you find the vertex of a quadratic equation. Now what is a vertex of a quadratic equation? Vertex of a quadratic equation is its lowest or the highest point. Now either a quadratic equation will have a highest point or either it will have a lowest point. When does it have a lowest point? When the quadratic equation is, let's suppose the quadratic equation is of this form. If this number a is positive, then the quadratic equation is going to be of this kind. And if this number a is negative, then the quadratic equation is going to be of this kind. right? So this is how the quadratic equation behaves. Now this one is going to have a lowest point and this one is going to have a highest point, and both these points are known as the vertex of the quadratic equation. Now, how do you find the vertex of a quadratic equation? Now, here's one hint, here's one thing that I'm going to give you. A quadratic equation is always symmetric with respect to its vertex. So what do you mean by that? It's symmetric with respect to its vertex. That means if I draw a line from the vertex, this side of the quadratic equation is an exact replica of this side of the quadratic equation. So if I draw a line like that, this side of a quadratic equation is an exact replica of this side of the quadratic equation. That means this point lies halfway between this line and this line. That is, this point lies halfway between this point and this point. And what are these 2 points, guys? These 2 points are nothing but the roots of the equation, isn't it? So that means if you have the two roots of the equation as x1 and x2, the x coordinate of the vertex, this is the x coordinate of the vertex, is actually going to be equal to x coordinate of the vertex is actually going to be equal to just simply the sum divided by 2, which means halfway between x1 and x2, that is x1 plus x2 divided by 2. So that means if you have both the roots, you can actually find the x coordinate of the vertex. Fine. So if I have this equation right here, let's say that is y is equal to x square minus 5x plus 6. So you already know that this actually looks like this, where this is 2 and this is 3. So I want to find what is this. That is the x coordinate of this vertex. So the x coordinate of this vertex is actually going to be simply 3 plus 2 by 2, which is 5 by 2, which is 2.5. So that means x coordinate here is going to be 2.5. You want to find the y coordinate? Just substitute 2.5 in this equation. So the y coordinate is just going to be equal to 2.5 square. I'm just substituting x as 2.5 minus 5 into 2.5 plus 6. So this actually will give you the y. Whatever y comes here will actually come here. So you will have the coordinates of the vertex. Isn't that easy? That's very, very easy. So I'm just gonna summarize what I did here, right? So first thing is solving the equation using splitting the middle term is to split the middle term. So what you do is, if you have an equation y is equal to x square plus 5x minus 6, x square minus 5x plus 6, so you split the middle term in such a way that let's suppose you split it in p and q in such a way that the product of p and q is the product of 6 and 1, and the sum of p and q is actually equal to -5. Fine. So that's splitting the middle term. Next thing is using the formula. So if you use the formula, that means the two roots of the equation are going to be equal to minus b plus or minus square root b square minus 4ac over 2 times a. And the vertex of the equation is actually going to be the x coordinate of the vertex of the equation or of the parabola is just going to be the average of these two numbers. Fine. So I hope that's fine, guys. I hope you understood this point clearly here. Now, there's one more thing about the formula. What is that? That is, so let me go ahead and write the formula here, guys. So you know that you have a quadratic equation, and this is x1 and this is x2. And you know x1 and x2 of the quadratic equation. So let's suppose the quadratic equation is ax squared plus bx plus c. So x1 and x2 is given as minus b plus or minus square root b square minus 4ac divided by 2 times a. So what am I trying to say here is, so you have this formula. Now this thing over here, it's pretty important for the equation. This thing over here is known as determinant. What is this known as? The determinant. It determines a lot of things. Why? Because for x1 and x2, minus b over 2a is something which is same for both of them. The difference between x1 and x2 is this value, that is b square minus 4ac. So if this b square minus 4ac is a positive number, that means it's greater than 0, then what is going to happen? You're going to get two separate values for x1 and x2. That means you're going to get two real and distinct roots, isn't it? So you're going to get two real and distinct roots. So that means your graph is going to cut the x-axis at two real points. So it is going to cut the x-axis at 2 points. But if I say that b square minus 4ac is actually equal to 0, that means what? That means your roots x1 and x2 both are equal to minus b over 2a, because this is 0. That means if this is 0, you're going to get a single real root, isn't it? So you're going to get a single real root. So one of the example of such an equation is x plus 1 whole square is equal to y. The only root here is x is equal to minus 1. That is the only value of x where y will be 0. So that means you have a single root. That means your graph is just going to kiss the x-axis like this. It's not going to cut it, but it's just going to kiss it, like right here. And the next thing is when b square minus 4ac is actually less than 0. So if it is less than 0, what happens is that means you have your x1 and x2 value are equal to minus b plus or minus square root a negative number divided by 2a. And square root of negative number are imaginary numbers, isn't it? So square root of negative numbers are nothing but imaginary numbers. They're not real. That means your values of x1 and x2 are going to be imaginary. That means you're going to get two distinct imaginary roots. What are you going to get? You're going to get two distinct imaginary roots. That means your graph is going to hang in the air. It is not going to touch the x-axis at all. Right? And both the roots are going to be the conjugates of each other. Both the roots are going to be conjugates of each other, which means if one of the root is 2 plus 3i, another root would be 2 minus 3i. So they're just going to differ by a positive and a negative sign, because that is what's going to happen. One root is going to be positive of something and one root is going to be negative of something. So I'm going to repeat the whole information again. So if you have a quadratic equation set like this here, and you're going to have two different roots, and this is the formula which actually gives you the two different roots. So you're going to have first root is going to be b square minus 4ac. If that is greater than 0, if b square minus 4ac, which is the determinant, is greater than 0, that means you're going to get two different values for the roots. That means you're going to get two real and distinct roots. They're going to be different from each other, and the graph is going to cut the x-axis at two different points. Another thing is when b square minus 4ac is equal to 0, that means this is not going to exist at all. That means you're only going to get a single root, which is minus b over 2a, and your graph is just going to kiss the x-axis. Another thing is when b square minus 4ac is actually less than 0, that means this is going to be a negative number. That means you're going to get imaginary roots. That means your roots are going to be imaginary. Your graph will hang in the air. It will never cut the x-axis. And both the roots are going to be conjugates of each other. If one root is 2 plus 3i, another root is 2 minus 3i. I is nothing but square root of minus 1, guys, right? I is nothing but square root of minus 1. If one root is 4 plus square root of minus 5, another root is going to be 4 minus square root of minus 5. So they're going to be conjugates. That means one is going to be positive and one is going to have a negative number here. So I hope this is fine, guys. I hope you understood how do you solve a quadratic equation using these two methods. The first method is splitting the middle term, and the second method is using the formula. Well, there's the third one as well, which is not that widely used, but yeah, it's important because it actually tells you something more about quadratic equations. Now, what is that formula? That method, the third method of solving quadratic equations, is completing square methods. So another method of quadratic equation of solving the quadratic equation is it's the completing square method. Fine. Now, what is a completing square method? So in a completing square method, so let's suppose if I say your quadratic equation is y is equal to x square. So if your quadratic equation is y is equal to x square, it's actually going to look something like this. Let's suppose what do I do is I move the quadratic equation this up by, let's say, k units. So let's suppose, how will this look like? This is going to look like y is equal to x square plus k. So your graph will actually move up by k units. And let's suppose I move it right by, let's suppose, h units. So if I move it right by h units, this one, how is going to look like? This is going to look like y is equal to x minus h whole square plus k. So it's going to move, so this was 0 comma k. Now it's going to move right by h units. That means this is going to be h comma k. So this is another form of quadratic equation, which is y is equal to x minus h whole square plus k, in which h and k are the vertices of a quadratic equation. So this is the completing square method of quadratic equation, that is y is equal to x minus h whole square plus k. So this is the quadratic equation, and these are the vertices of the quadratic equation. So if I say y is equal to x minus 2 whole square plus 3, that means the quadratic equation has vertices. Vertices of quadratic equation is 2 comma 3. That means this is the quadratic equation, that is 2 comma 3. Fine. So for SAT, you just need to know this. You don't need to know anything more. So this is the completing square method. Fine. So I hope you understood this, guys. So if you by chance, instead of seeing this as the equation, so let's suppose instead of seeing this as the quadratic equation, that is y is equal to ax square plus bx plus c, you can also see the quadratic equation as y is equal to x minus h whole square plus k. So in this case, the vertices, the vertices, so the vertex of the function, of this quadratic function, is actually given by the x coordinate is actually given by the average of the roots. But in here you don't have to actually do that. You can clearly find the vertices, that is just simply h comma k. So if this is x plus 2 whole square plus 3, so the vertices are going to be equal to negative 2 and 3. So the vertex is actually going to be at negative 2 comma 3, because this is positive 2, and see the formula right there. So it has to be negative 2 comma 3. So that's the third method of solving quadratic functions. So I hope you got this, guys. I've actually lined up some questions for you which are very, very SAT like, the new SAT like, and we're actually going to solve those questions. So I hope you understood this video here, in which I talked about how do you solve quadratic equations, right? How do you solve these quadratic equations? And so I'm just going to give you a summary of that. So let's suppose if I summarize all of it, what I've just said, that it can be solved in 3 methods. The quadratic equation can be solved in 3 methods. First is you split the middle term, second is use the formula, and third is you actually use the square method. So in the square method, what you need to know about the SAT is y is equal to x minus h whole square plus k. In this, the vertex is actually given as h comma k. So the formula is minus b plus minus square root b square minus 4ac over 2a. That actually gives you the two roots of the equation. And how do you find the x coordinate of the vertex? X coordinate of the vertex is actually found by just adding both the terms and dividing it by 2. And split the middle term. So if you have y is equal to ax square plus bx plus c. So how do you split the middle term? You split b in such a way such that the product of those two numbers is the product of these numbers, and the sum of those two numbers is actually equal to b. There's one small bit of thing which I actually remembered right now that I want to share with you, is that if you have a quadratic equation that is y is equal to ax square plus bx plus c, then let's suppose you have two roots x1 and x2. The sum of the roots is equal to minus b over a, and the product of the roots is actually equal to c over a. Very, very important. I've actually derived it one of my quadratic equations content videos. You can see the derivation there, but this is what I want to share. The sum of the roots is minus b over a, and the product of the roots is actually equal to c over a. This is something that you can derive from the formula, that is minus b plus or minus square root b square minus 4ac divided by 2a. You can see, you can add the roots, they will give you b over a, and you can multiply the roots, because one of the roots is going to be equal to minus b plus square root b square minus 4ac over 2a, and one of the roots is going to be equal to minus b minus square root b square minus 4ac over 2a. If you multiply the roots, you'll get this. If you add the roots, you will get this. So the sum of the roots is minus b over a, and the product of the roots is c over a. So let's go ahead and do the questions, guys, right? So just to thank you for this video, guys. So thank you very much for watching this video, and just don't forget to watch the part 2 of this, in which I'll be solving the questions related to the new SAT, right? So I hope you understood whatever I was supposed to explain here, guys. Thank you very much for watching this video. Make sure that you email us your feedback at this email address, visit our website, and also give us valuable like at this Facebook page. So thank you very much for watching this video, guys, and don't forget to watch the second part in which I've solved the questions. So thank you very much. I'll see you in the next one.